Today's lesson is 1.4. Please open up your textbook to page 26. Okay, our purpose today is to find all the factors of a given number by identifying factor pairs. Now, a factor pair is when you can multiply two numbers together to get any given number as an answer. Let's take a look at the example. Talks here about 2 is a factor of 10 and 2 times 5 equals 10. So 5 is also a factor of 10. So the pair 2 and 5 is called a factor pair. Now 10 also has another factor pair, 1 times 10. Because I can do 1 times 10 to get 10 or 2 times 5 to get 10, it means that 10 is a composite number. Okay, example 1 talks about finding factor pairs. Now, oftentimes when we're talking about any given number, there can be a lot of different factor pairs. And if you're not following a certain process to make sure that you're not overlooking a factor pair, it would be really easy to leave one off. So, as you're finding factor pairs in today's lesson and future lessons, I really want you to follow this method, please. So the problem says a brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has the same number of members. How many possible arrangements are there? Okay, this is a factor pair problem where we're looking at all the different combinations of numbers that can be multiplied together to get 30. So the first problem that we have is 1 times 30. You're always going to start with the number 1 because 1 and the number are always a factor pair. Then notice the next number I'm using here is 2. 2 times 15. I'm going to keep going, so talking about factors, so my first column goes up, my second column of numbers is going to get smaller. So my third factor pair that I'm going to use is 3 times 10. 3 times 10 also equals 30. Now notice, my next factor pair is 5 times 6. The reason for that is if I use the number 4, there's nothing I can multiply by 4 to get 30. And it has to be a whole number. So notice I've skipped the number 4. I have 5 times 6, and then the next factor pair here is 6 times 5. Now, when I do 6 times 5, it's a repeat of the factor pair that I have above it. So actually, when you're listing your factor pairs, as soon as you start getting repeats, it's a sign that you can stop. Now, what I also tell students is your first column counts up, your second column counts down, and these two numbers are going to meet in the middle. Notice 5 times 6, there's no factors in between. Now, in this problem, they want to know what the different possible combinations are. And 5 rows of 6 is different than 6 rows of 5. So they have continued to list the factor pairs down here, and they get a total of 8 combinations. I'm not going to require that you ever write repeats. So as soon as you come to the factor pair, if your first number is bigger than your second number, you know that you're done and you've already included everything you need to include. Okay, let's take a look at a few other examples. I've already actually listed the factor pairs out for these numbers to show you the method. Number 1 is 18, so I'm going to do 1 times 18, 2 times 9, 3 times 6. Now my next number would be 4, but I can't multiply 4 times anything to get 18. So my next number would be 5 to try. 5 I cannot multiply by anything and get 18. When I get to the number 6, the 6 is already here in my second column, so I actually know that I'm done. I found all the factor pairs there are. Let's take a look at number 2. For 24, I can do 1 times 24, 2 times 12, 3 times 8, 4 times 6. My next number is 5, but 5 cannot be multiplied by anything and get 24. My next number to try is 6, and 6 is already listed over here, so I know I've got all of the answers. Okay, finally, 51. I can multiply 1 times 51 and get 51. I can try 2, but I know it won't work because 51 is an odd number, so I'm going to skip the factor 2 and go on to 3. 3 times 17 will also give me 51. Now, what I would need to do is go ahead and try 4, 5, 6, etc. until I got to the number 17. And when I get to something in the second column, I know I'm done. I'm not going to go through all of those steps because I do know that there are no other factors for the number 51. Now, if you weren't sure, let's say you thought maybe 7 was, if you do 51 and divide it by 7 on a calculator, you're going to get a decimal. Anytime you get a decimal, you know it is not a factor. Okay, let's talk about prime factorization. Prime factorization of a composite number is the number written as a product of its prime factors. Now, I'm guessing in elementary that you all completed factor trees, or maybe you have done it but forgot what it looks like. Now, we can use a factor tree to help us find the prime factorization of a number. A factor tree is complete only when all of the prime factors appear. So, here's the example of a factor tree for 60. For 60, I can do 2 times 30. 2 is prime, so it's been circled. Now I'm going to go on to 30. To get 30, I can do 2 times 15. That equals 30. 2 is prime, but 15 is composite, so I have to keep on going. I know that 3 times 5 equals 15, and 3 and 5 are both prime. So I know now that this is the prime factorization. 2 times 2 times 3 times 5. If I multiply those numbers together, I will get 60. Now, you can also write it with an exponent, 2 to the second power times 3 times 5. Either way is correct. One thing I want you to notice, though, is that the numbers are written from least to greatest. So notice they started with 2, 2, 3, 5, or 2 squared, then the 3, and then the 5. It would not be correct to, for example, write 3 times 5 times 2 times 2. We want it in order from least to greatest. All right, let's take a look at an example. Example 2, writing prime factorization. It asks you to find the prime factorization of 48. So for tree number 1, I'm going to do 2 times 24, circle the prime number, keep going with the composite. 2 times 12 is 24, 2 is prime, 12 is composite, so I keep going. 4 times 3, 3 is prime. Then 4, I can do 2 times 2. So the prime factorization of 48 is 2 times 2 times 3 times 2 times 2. Now, they've just copied the numbers down here in the order that they came across them, but it should be rewritten as they did down here, starting and going from least to greatest. Now, I want you to take a look at tree 2 because you may be thinking, what if I didn't use 2 times 24? Will I still get the same answer? Let's take a look. They used 3 times 16, circled the prime, kept going with 16. 2 times 8, 2 is prime, 8, they kept going. 4 times 2 is 8, 2 is prime, but 4 is composite, so then they kept going with 2 times 2. Now notice, they still ended up with the same numbers. 3 times 2 times 2 times 2 times 2. So we have 2 to the 4th power times 3. Either way that you work it out, it doesn't matter which factors you choose. In the end, you're still going to get the same answer. Okay, we're going to skip example 3 and go straight to the on your own problems. I am going to have you skip problem number 8. You do not have to do 462. I'm not going to give you numbers that big. But do please make a factor tree for problems 5, 6, and 7 in your notes.